Every tree holds a secret diary, but not written in ink. Hidden in the wood itself are rings, each marking a year of growth, each carrying a coded message about rain, drought, fire, and even volcanic eruptions. These circles, silent yet enduring, stretch back centuries and, in some cases, thousands of years. They are nature's own archives, waiting to be read. Today, as climate change dominates global headlines, scientists have turned to these unlikely historians. By studying tree rings, a field known as dendrochronology, researchers can reconstruct weather patterns long before satellites or thermometers existed. These records do not just tell us about the past, they help us anticipate the future. In this documentary, we'll uncover how tree rings became one of the most reliable climate archives on Earth. From their discovery by early pioneers to the techniques that unlocked their secrets to the profound role they play in today's climate debates. This is the story of how wood became history. Long before scientists measured carbon levels in ice cores or calibrated satellite sensors, humanity sensed that trees were more than just sources of shade, fruit, or timber. Ancient cultures often viewed them as living symbols of time. The Norse imagined Yggdrasil, the world tree that linked realms. In Chinese tradition, pines represented endurance across centuries. Even without scientific instruments, people intuited that trees contained a rhythm of years within their trunks. Yet it wasn't until wood was cut and studied closely that a hidden code began to reveal itself. Farmers in medieval Europe noticed that planks of oak bore alternating light and dark bands, patterns that seemed to align with seasons of growth and dormancy. These observations, though unsystematic, hinted that trees carried within them a calendar written by nature itself. By the Renaissance, curiosity grew sharper. Scholars such as Leonardo da Vinci sketched cross-sections of trunks, noting that the width of rings varied with rainfall. He wrote that trees record the passing of years in their growth, an observation astonishingly ahead of its time. Still, his insights remained isolated, more artistic reflection than rigorous science. The idea truly began to shift in the 18th and 19th centuries, when naturalists systematically catalogued trees not just for botany, but for what they might say about environments. Explorers bringing back exotic woods from Asia, Africa, and the Americas noticed that each climate left a distinct fingerprint on the growth of its trees. Rings were wide in fertile years, narrow in drought, scarred by fire. This was no random texture, it was memory etched into wood. At the same time, archaeology and geology were developing their own timelines. Layers of soil, strata of rock, and ruins of past civilizations told stories of time. Yet all these records had gaps. What tree rings offered was different, a year-by-year account, precise and continuous, accessible in ordinary forests as well as ancient ruins. The seeds of dendrochronology, the science of tree ring study, were planted in these centuries of observation and speculation. Before the discipline had a name, there was already the intuition that trees were witnesses, that their bodies quietly stored the history of climate and time. The stage was set for a breakthrough when one determined scientist in the early 20th century would transform scattered insights into a rigorous method, forever changing how we read the natural past. The birth of dendrochronology, the formal science of tree ring study, can be traced to one man, Andrew Ellicott Douglas, an American astronomer working in the early 20th century. At first glance, Douglas had little reason to turn his telescope from the heavens to the trunks of trees. But his true obsession was cycles, specifically how solar activity influenced the Earth. In the 1890s, Douglas became convinced that variations in sunspots could affect climate. If the sun waxed and waned in energy, perhaps rainfall and temperature on Earth fluctuated too. But how to prove it? Meteorological records were too short, spanning only a few decades. Douglas needed something far older, a natural archive of climate that stretched back centuries. That is when his eyes fell upon the forests of the American Southwest. Cutting through logs of ponderosa pine, Douglas noticed something remarkable. The growth rings widened in wet years, when rains were plentiful, and narrowed during dry spells. Year after year, each tree recorded its own diary of survival. And if one tree's record could be matched with another's, a continuous sequence could be built, a timeline stretching backward far beyond living memory. His early work was painstaking. Douglas compared the widths of rings from multiple trees, searching for patterns. When one tree's last decades matched another's first decades, he could cross-date them, extending the chronology further back in time. The method worked, like stitching together fragments of a tapestry until the picture became whole. By 1919, Douglas had established the first extended climate chronology in North America, covering nearly 500 years. Scientists took notice. For the first time, climate history wasn't guesswork or anecdote. It could be read year by year with precision as sharp as a calendar. But the most dramatic breakthrough came when archaeologists sought Douglas's help. Ancient pueblos in the Southwest, such as those at Mesa Verde and Chaco Canyon, had long puzzled researchers. When were they built? What caused their abandonment? By matching the timber beams from these ruins with his growing ring chronology, Douglas discovered exact felling dates. Suddenly, lost civilizations could be dated not within centuries, but to the very year. This was revolutionary. Dendrochronology was no longer just a tool for astronomy or climate. It became a bridge between the living forest and the ruins of human history. The first working system had been proven. Trees could indeed serve as precise historical records. Reactions were mixed at first. Some archaeologists marveled at the precision, while others doubted that wood could be a trustworthy chronicle. Yet as more samples were tested and the method repeated, skepticism gave way to recognition. By the 1920s, Douglas's tree ring laboratory at the University of Arizona had become the nucleus of a new science. The spark had been lit. What began as an astronomer's side project now promised to unlock centuries of climate, culture, and environmental change, with trees as the quiet witnesses. The story of dendrochronology does not end with laboratory charts or climate models. Its true legacy lies in how it reshapes our understanding of history, not just natural history, but human history itself. Tree rings have become timekeepers for archaeology. By anchoring wooden beams, shipwrecks, and ancient tools to exact years, scientists have corrected timelines once thought settled. Viking expansion in North America, for instance, was dated precisely to 1021 CE thanks to tree ring, evidence marked by a spike in solar radiation. Similarly, medieval European architecture can now be traced with near forensic accuracy, linking construction booms to favorable climates and collapses to cold snaps. This precision has revealed an intimate link between climate and human destiny. The fall of the ancestral Puebloans in the American Southwest, the Mongol withdrawal from Europe, even the decline of the Mayan cities, all now understood in sharper relief through dendrochronological records of droughts and famines. What once seemed like political or military mysteries are increasingly recognized as stories written in wood. The long-term impact of tree ring science is also the creation of global climate chronologies. Today, massive international projects are stitching together records from different continents into unified timelines that stretch back tens of thousands of years. This network of time allows us to see global events in synchrony, how a volcanic eruption in Indonesia dimmed the skies in Europe, how El Niño rippled through Africa and the Americas centuries ago. Tree rings thus serve as the connective tissue of Earth's history, the bridge between continents, between cultures, between natural and human stories. They make the invisible visible, the pulse of the planet over time, but perhaps the deepest legacy is cautionary. Civilizations that ignored the warnings of environmental stress saw their foundations crumble. Today, tree ring science offers not just knowledge but perspective. It reminds us that history is littered with societies that pushed their ecosystems too far. The long arc of tree ring records teaches that resilience has thresholds, and those thresholds, once crossed, can trigger irreversible change. In this way, dendrochronology itself has become a kind of monument. It is not just a scientific field, but a cultural inheritance, a reminder that every living tree is both witness and participant in history. Just as ancient scribes inscribed clay tablets or monks copied chronicles, trees have kept their own silent record. Now that we can read it, we bear responsibility for what it tells us. The falling action of this story, then, is not one of decline, but of realization. The tree rings show us that humanity is part of a continuum stretching far beyond the span of empires or lifetimes, and in that recognition lies both humility and hope. Humility in facing the vastness of time, hope in learning from it. The spark that Andrew Ellicott Douglas ignited in the early 20th century did not remain a curiosity. Over the next century, dendrochronology, the study of tree rings, expanded from a regional technique into a global science, transforming archaeology, climatology, and even modern environmental policy. Its rise was not a straight line, but a story of steady milestones, rival methods, and international collaboration that stretched across decades. After proving that tree rings could date ancient pueblos, Douglas formally founded the Laboratory of Tree Ring Research at the University of Arizona in 1937. This institution became the first dedicated center for dendrochronology, training generations of scientists. By this time, chronologies extended over 1,000 years, and the method was gaining credibility among archaeologists and climatologists alike. The reliability of cross-dating, matching ring patterns across trees, became the gold standard. Other dating methods like radiocarbon had not yet emerged, giving tree rings a unique authority. The Second World War spurred advances in many sciences, and dendrochronology was no exception. Timber was a critical material, and the ability to determine the origin and age of wood had practical applications. But the biggest challenge came in the late 1940s with the invention of radiocarbon dating by Willard Libby. Suddenly, archaeologists had a new method to measure the age of organic material, seemingly without the painstaking work of tree ring matching. For a moment it seemed dendrochronology might be eclipsed, but it was Douglas's discipline that turned the tide. Radiocarbon dating required calibration because levels of carbon-14 in the atmosphere were not constant through time. Tree rings, with their exact annual record, provided the calibration curve. In effect, dendrochronology became the backbone of radiocarbon science, ensuring its accuracy. Rivalry gave way to symbiosis. As new laboratories opened in Europe, particularly in Germany and the UK, the field broadened. European oak chronologies stretched back thousands of years, far beyond the pine forests of Arizona. In Ireland, long-buried bog oaks extended sequences into prehistory, allowing researchers to reconstruct rainfall patterns and societal collapses in the Bronze Age. In Scandinavia, pine chronologies began tracing shifts in glacial advance and retreat. The discipline also began intersecting with climate science more directly. In the age of the Cold War, understanding past climate cycles became politically important. Reconstructions of drought and rainfall fed into models of agricultural planning, water management, and even nuclear test site selection. By the late 20th century, dendrochronology was no longer confined to regional puzzles. Chronologies in Europe now reached back over 8,000 years, while bristlecone pines in the White Mountains of California revealed annual records more than 4,500 years old. the oldest living tree chronologies on Earth, the rise of computing transformed the field. Instead of hand-measured ring widths, digital scanners and statistical software allowed scientists to process thousands of samples with speed and accuracy. Networks of chronologies could now be stitched together globally, creating vast datasets for climate reconstruction. At the same time, dendrochronology began contributing to historical debates. Tree rings confirmed the climatic downturn of the so-called Little Ice Age between the 14th and 19th centuries. They shed light on the collapse of civilizations, from the droughts that struck the Maya to the famines that reshaped medieval Europe. Trees were no longer silent witnesses. They were active voices in rewriting human history. As climate change rose to the forefront of global discourse, tree rings found a new central role. Long-term reconstructions offered a baseline against which modern warming could be measured. They revealed that recent decades of warming and drought were unprecedented in the context of the last millennium. Policymakers, from the Intergovernmental Panel on Climate Change, IPCC, to national agencies, cited dendrochronological data to argue for urgent climate action. At the same time, refinements in isotopic analysis allowed researchers to move beyond simple ring widths. The chemical signatures locked within each ring revealed past temperatures, volcanic eruptions, and even atmospheric circulation patterns. By the 2010s, dendrochronology had become a cornerstone of paleoclimatology, A2A, truly global science. From Siberian larch to Patagonian beech, from African baobab to Himalayan cedar, the Earth's forests were now understood as libraries of climate memory. In less than 100 years, dendrochronology evolved from Douglas's personal quest into an indispensable global discipline. Its milestones, archaeological dating, radiocarbon calibration, international expansion, digital precision, and climate policy, mark the ascent of tree ring science from a niche curiosity to a world-shaping field. The next great chapter, however, would not just be about constructing timelines. It would be about how society embraced this knowledge, how governments, industries and communities began to act upon the voices of the trees. By the dawn of the 21st century, dendrochronology was no longer confined to academic journals or obscure research laboratories. It had entered the mainstream, shaping climate policy, cultural heritage preservation, and even public consciousness. The once niche science of tree rings had become a global language, one that policymakers, conservationists, and ordinary citizens could understand. The revolution began when tree ring records were directly linked to pressing societal questions. In the American Southwest, reconstructions of centuries-long droughts, including the infamous mega-droughts of the medieval period, revealed that the modern water system was designed for an unusually wet era. This data shook planners and governments, forcing a re-evaluation of water rights, dam construction, and agricultural policies. Similar revelations spread globally. In China, dendrochronology exposed patterns of recurring droughts that aligned with dynastic rises and collapses, giving historians and policymakers alike a sobering lesson. Climate stress could fracture even the most powerful empires. In Africa, tree ring data informed famine early warning systems, helping international agencies prepare aid before catastrophe struck. Tree rings also entered the cultural realm. Archaeologists used them to date Viking ships, medieval cathedrals, and even Stradivarius violins. Each piece of timber, once thought timeless, now had a precise birth year. Museums and restoration projects increasingly relied on dendrochronology, not just for authenticity, but for storytelling. The wood itself became a historical witness, carrying the signature of the forest it came from. Communities began to see tree rings not as abstract science, but as part of their heritage. In Ireland, The bog oak chronologies became intertwined with national history. In Japan, temple builders turned to dendrochronology to align modern repairs with centuries-old traditions. Even indigenous communities, long aware of the voices of trees, found their knowledge validated by scientific tools. Perhaps the most profound shift was in public perception. Popular science media showcased the idea that each ring was a time capsule preserving moments of volcanic eruptions, solar storms, or great droughts. Documentaries, museum exhibits, and even school curricula introduced children to tree rings as natural history books. The appeal was simple but powerful. Anyone could look at a cross-section of a log and see history written in alternating light and dark bands. Unlike satellite data or abstract graphs, tree rings were tangible, visible, and human-scaled. They made climate change understandable not as a distant theory, but as a lived reality inscribed in wood. By the 2010s, tree rings had transformed from passive records into active warnings. Studies of North American forests revealed that rising temperatures and prolonged droughts were now pushing trees beyond their historical survival limits. Ancient bristlecone pines, once considered nearly immortal, showed signs of stress unprecedented in their thousands of years of existence. This shift marked a societal turning point. The trees were not just telling us about the past, they were warning us about the future. Governments began incorporating dendrochronological data into climate models, forest management strategies, and disaster preparedness plans. Insurance companies, agricultural corporations, and even military strategists consulted long-term climate reconstructions to assess risk. Perhaps most remarkably, dendrochronology created a shared narrative across cultures and nations. Whether in the icy boreal forests of Siberia, the rain-soaked Andes, or the arid Southwest, tree rings told the same story. Humanity's fate was bound to the climate, and the climate was etched in wood. By connecting archaeology, heritage, policy, and climate awareness, dendrochronology achieved what few sciences have managed. It bridged the gap between the lab and the living world. The voices of trees were no longer whispers for specialists. They had become part of a global conversation about survival, responsibility, and shared history. The revolution was complete. From a scientist's curiosity in Arizona to a worldwide tool that reshaped how societies viewed their past and their future. But the story was not over. Ahead lay the challenges of the present, the urgent warnings of trees in a rapidly warming world. If dendrochronology's rise was a revolution, the present moment represents its most dramatic test. For the first time in human history, trees are recording not only natural cycles, but the direct imprint of industrial civilization. And the signals they carry are alarming. Modern tree ring records show growth patterns unlike anything in the last several millennia. In regions like the American West, rings have thinned dramatically in response to record-breaking droughts, compounded by unprecedented heat. Studies reveal that recent decades rival, and may even surpass, the great mega-droughts that toppled ancient civilizations. The message is stark. The climate stresses that once destroyed empires are returning, this time on a planetary scale. In Siberia, trees have preserved the fingerprints of nuclear fallout, with abnormal growth linked to Chernobyl and later radiation events. In the Amazon, deforestation is changing rainfall cycles so rapidly that trees' rings no longer follow their historical rhythm. What was once a natural archive has become a ledger of human disruption. One of the greatest challenges to dendrochronology emerged in the late 20th century, the so-called divergence problem. In certain northern forests, tree ring growth no longer tracked rising temperatures as reliably as before. For decades, climate skeptics seized on this anomaly to claim the science was flawed, but research has since revealed the cause. Trees under extreme modern stress from pollution, ozone depletion, and warming beyond their natural tolerance no longer behave as they once did. This discovery was a turning point. Far from discrediting dendrochronology, it underscored its importance. The divergence problem was not a weakness, it was a warning. The trees were showing us the limits of life under accelerating change. Tree rings have also become vital in understanding the Anthropocene, the proposed new epoch defined by human impact. In the wood of forests worldwide, scientists have identified signals of industrial soot, nuclear bomb testing, and rising carbon dioxide. The year 1964, marked by peak radioactive isotopes from Cold War nuclear detonations, is visible in trees across the globe, a planetary timestamp carved into wood. In Chilean forests, volcanic eruptions linked to modern activity overlap with ancient rhythms of fire. In Africa, tree rings reveal not just drought, but the scars of overgrazing and desertification. Everywhere, the trees are now bearing witness to the weight of human actions layered upon natural cycles. The most dramatic realization is not just what the trees say about the past, but what they imply about the future. Ancient bristlecone pines in California, some older than the pyramids, are showing stress signals unprecedented in their thousands of years of survival. For scientists, this marks a sobering moment. If even Earth's oldest living organisms are faltering, the scale of modern change is beyond historical precedent. Governments and global institutions have begun listening more closely. In 2021, Dendrochronological studies were cited in UN climate reports as critical independent evidence for the speed and severity of warming. By aligning tree ring records with ice cores, corals, and modern satellites, researchers created a unified timeline showing that today's climate trajectory is not just unusual, it is unmatched in at least 11,000 years. Yet the climax of this story is not only scientific, it is cultural and moral. Dendrochronology forces us to see ourselves in the long arc of history, alongside civilizations that flourished and collapsed under climate stress. The trees remind us that resilience has limits, that balance can be broken, and that survival depends on adaptation. The turning point is here. The tree rings that once quietly recorded centuries are now screaming warnings in wood. The question is whether humanity will listen and act before the story narrows into rings of collapse. When we step back from the dense timelines and scientific graphs, what emerges from tree ring science is not merely data, but perspective, a way of situating ourselves in the grand interplay between climate and civilization. Trees remind us that no year is ever lost. A drought, a flood, a volcanic eruption, each event leaves its fingerprint. This permanence forces us to confront the reality that our own era will also leave a mark. Future scientists, centuries from now, will read the scars of industrial pollution, nuclear tests, and global warming etched in the wood of our forests. In this sense, tree rings are not just about the past. They are already chronicling us. From the collapse of the Mayans to the famines of medieval Europe, dendrochronology shows that climate is not a background actor, but a central driver of history. This reframing carries profound relevance for the present. As the world grapples with shifting rainfall, rising temperatures, and intensified droughts, tree rings offer not only warnings, but case studies of how societies succeed or fail in adapting. Perhaps most inspiring is how dendrochronology erases boundaries. A tree in Arizona, one in Mongolia, and another in Patagonia may all carry signatures of the same volcanic eruption. The science reminds us that climate shocks have always been global, binding humanity in a shared fate. In today's era of climate negotiations, this lesson is impossible to ignore. The environment has no borders. Tree ring studies now inform water management in the American West, agricultural policy in Africa, and wildfire risk assessments in Australia. Insurance companies, governments, and conservationists all rely on insights drawn from dendrochronology to plan for uncertainty. In a world bracing for intensified extremes, the lessons written in wood are not abstract history, they are survival tools. In the end, the resolution is clear. Trees teach us accountability. Their rings testify to past mistakes, but they also reveal pathways to resilience. To ignore them would be to squander one of nature's most eloquent archives. To listen is to recognize that history and climate are not separate stories. They are one. From the silent forests of Europe to the high deserts of the American Southwest, trees have stood as witnesses and record keepers of our shared past. Their rings carry the voices of centuries, droughts that toppled empires, volcanic winters that reshaped societies, and steady cycles of growth that nurtured civilizations. By unlocking their stories, we have gained not only a history of climate, but also a mirror for our own age of uncertainty. Tree rings remind us of two truths. First, that nature never forgets. Every action leaves a trace. Second, that humanity has always been bound to the rhythms of climate, adapting, struggling, and enduring in the face of change. Today, as we confront a rapidly warming planet, their message is urgent. The archives of the past can guide the decisions of the future. If you found this journey through the living time machines of our planet as fascinating as we did, don't let it end here. Like this video, share it with others who value history and science, and let us know your thoughts in the comments. How do you think tree ring science will shape the way we navigate climate change today? And of course, subscribe to our channel for more deep dives into the stories that connect history, innovation, and the fate of our world, because the rings of tomorrow are being written right now.